Welcome to Parabolas Part 1. This message is sponsored by Dutch Brothers. Dutch Brothers, get your caffeine here. I emailed you some stuff that you're going to need, and so I assume that already you've done the study notebook and you've got out your textbook. You're going to want to have the Intro to Conics page handy with you as you watch the video. It'll be a place where you'll be filling in numbers 1 through 8. Also, you need to be taking notes, and I'll tell you what specifically I want you to write down. Well, let's start with getting out that Intro to Conics page, and as you see what happens, you're just going to answer each of the questions. So I'm going to start by moving to page 1.2. And all what I'm going to do here is I'm going to scroll through these. Let me start here with conic number 1 and briefly describe in your own words how this conic section is formed. You want to basically describe it in terms of the plane cutting through the napped cones. So there's conic number 1. Remember, hit pause if you need to stop me talking and write. Here's conic number 2, the ellipse. So pause and write a brief description of how that section is formed. Here's conic number 3, the parabola. Please pause and write a description of how this section is formed. And there's the 4th conic section, the hyperbola. Please pause and write a description of how this section is formed. On to page 2.1. Point F is called the focus. You can see it there on the picture. What is the line through point F perpendicular to the directrix called? You just did it in your vocabulary. What is that dotted line called? That's number 2. Number 3, line D is called the directrix. What is the relationship between line D and the dashed line through point F? Number 4, observe as I drag point P along the curve. What property seems to be true for all points along the parabola? Look up in the upper corner there, okay? What's going on? PD to PF. What is true? This is one way that a parabola is defined. That is going on. Now I'm going to drag point F around the screen. You'll answer number 5. See if the property from number 4 remains true. Please flip the page over. Let's look at page 2.2, number 6. I'm going to use my arrow buttons here, and I'm going to start with A. Here's the equation, and it tells me exactly what this is right now at all my settings down below. And I'm just going to change A in the equation, make it bigger, and I can go ahead and make it smaller. And all you need to do is describe as A gets bigger, what happens to the graph. As A gets smaller, what happens to the graph. Describe how the value of A affects the graph. Now here's H. H is this part inside the equation. Right now it's at 5, but as I increase that, what happens? As I decrease that number, what happens to the graph? In your own words. And number 8, as I adjust K. K goes up. As K goes down, please describe in your own words. You can cross off number 9 and 10. We are not going to complete those, and we're going to move on to something completely different. In your book, it demonstrates the math that goes from this basic principle here, that FP and P to Q, which they give a different letter in the book, that is constant. You see here the ratio of PF to PQ stays constant no matter where the point is along the parabola. So as using that as a definition for a parabola, they have boiled it down to the key concept that you see in the book. Now you need to make sure that you pause and you write that whole thing down in your notes, or as we suggested in class, that you write that down on maybe an index card, but in your notes or on an index card is going to be helpful because it's going to be your cheat sheet for interpreting all these parabolas. You write down the form, draw the pictures, go ahead and hit pause and then hit start again when you've finished that and you have it in front of you. I'm going to take you now through the 3 examples, or at least things like those 3 examples. I'm not going to do example 1 out of the book. You can see it there in the book. I'm going to do guided practice 1A. Once we figure out some things about the equation, once we have it in the right form, we can basically read all the things that we need in order to draw the parabola. Now I've got up here the form that we would have to use for this particular equation. Okay, you see that the y stuff is on the left and the x stuff is this part that's squared. It doesn't matter which one's on the left or the right. The thing that matters is what part gets squared and where is the 4p. So you can see we're determining whether the thing opens up or down, left or right. If p is positive, then it either opens up or to the right. If p is negative, it opens to down or to the left. If the x is squared, it's going to open up or down. If the y gets squared, it's going to open left or right. So once we figure out orientation there, we know which equation to use, and if we have it in the right form, we just pick the parts out, and then all the other stuff logically will fall into place. I think you're really going to like this. So I took that same equation, I did the math, and I put it in quadratic form, which we've done before, and this is what it looks like. Now you look at that equation there, and you see that there's nothing in this equation that tells me anything about the axis of symmetry. It doesn't tell me anything about the vertex, the focus, the directrix. It doesn't tell me anything about what this is going to look like. I have to graph it and check it out. So this form here is the boss. Okay, if we can get the equation in this form, we can pick out all the pieces. So here's our equation. 8 y plus 3 equals x minus 4 squared. What's h? Yeah, it's right there. 4. X minus h. K? It's y minus k. So k is negative 3. Now out here, 8, that is equal to 4p. So we do the pretty easy math there. P must equal 2. Orientation. Oh man, typing skills. Opens up. Vertex. It's H and K. The focus. That's H and K plus P. 4, negative 1. Axis of symmetry. X equals H. And the directrix, K minus P, or negative 5. And now you've got all these things that you can use to draw the parabola. Also on your calculator you have this tool here. You go to apps and you've got Conics. I know because I put it on the calculator. Go to Conics and we pick number 4, the parabola. We are looking at one that's in the form of number 2, and all we need to do is tell it H and K and P. H was 4, K was negative 3, and P was 2. When we hit the graph button and it draws the picture for us. You want to verify those points, you hit trace and scroll around the picture. So once you have those points, it's pretty easy to graph. Okay, next is example 2, which gives you a real world application, and if you're looking at the picture there in the book, it's the same thing that I showed you in physics class, the parabolic liquid mirror. I have a handout for you when you come to school. But this one's not quite in the right form. Here's how it starts out. X squared equals 44.8y minus 268.8, and we need it in this form right here in order to interpret the parts. So no problem, we can do that. I start off by putting it in as much of the form as I can, and I do that by dividing the right side by 44.8. And lo and behold, that 268.8 divided by 44.8 equals 6. So I'm almost there already because here's K and here's H. 44.8 equals 4 times P. So this is probably the best way to write it. And then we can interpret that and draw the picture. I think you want to pause and try to fill in HKP, vertex, axis of symmetry, and directrix, and all that stuff. And then I'll show you the answers here in just a couple seconds. Go ahead and hit pause. So here's our answers. I forgot about the focus. Maybe you thought about that. H is 0, K is 6, P is 11.2. The vertex is H and K. The focus, you got H and K plus P. Axis of symmetry, X equals H. Then the directrix, Y equals K minus P, or Y equals negative 5.2. You want to see what that looks like? You go to your TI, you pick the parabola, you just put in 0, 6, and 11.2, and you hit graph, and so that's the surface of that mirror. That's what it would look like if you're zooming in up close. You can scroll around and get some data points there. Got it? Okay, now on to things like example 3. I'm not going to use example 3 because you can go and read example 3. Example 3 is a really good one on a tricky one where you have to complete this, complete the square to put it in the right form. If you need help with how to complete the square, go back to page P12 in lesson 03, and it has the step-by-step thing and some practice there. You have to be able to do that to do these. So I'm going to take number 20 from your homework and show you how you would do that. And then I'll show you one that's even easier than this that you can do as well. So here's what number 20 looks like. It's kind of messed up. You have x squared, a y, and an x. So we need to get the x's on one side and the y's on the other, and that's the first thing I do. I'm going to rearrange. Remember, hit pause at any time if you need to take a breather and think about that. So I put 12y minus 33 on this side and the things with x on that side. I have to complete the square with this side. So I have to find half of b, which is negative 6, and then I'm going to square that, and that's what I add to both sides. Then I change the form. So here we go. Down here, step 1, half of b is negative 3. If I square negative 3, I get 9. So that side would be, if I'm going to be able to complete the square and write it in the x minus 3 squared form, it's x squared minus 6x plus 9. But if I add plus 9 to one side, I have to add plus 9 to the other side. So I put that right here. This side already has the plus 9 in it because that's just the form. If you expanded that, the plus 9's in there now. So we got to stay true. We have to put a plus 9 on both sides. In the one example in your book, they put a plus and a minus on the same side. That's the same exact thing. So once I do that and I add 9 to this side, that becomes negative 24. And then I factor the 12 out of the sides and I get y minus 2. And here we've got the right form, yeah? 12 equals 4p. So pause the sucker here and figure out what's HKP, and then the vertex, focus, axis of symmetry, and the directrix are all just going to flow from those answers. So H is 3, K is 2, P is 3, vertex 3, 2, focus can be calculated, axis of symmetry, no problem, directrix, got that one. Just make sure that we're working with the right form here, and then if you want to test it out on our calculator, put in 323 and hit graph, and you got that. Hit trace and follow some of the points. Ta-da! One more example of that kind of thing where you have to change the form. This one's really easy because it doesn't have any x squareds. We just need to get the x's and the y's away from each other. Let's start by subtracting 3 from each side, and it turns into this. Now I get the x's and the y's on opposite sides, and that turns into this. I just put it in the form so I can pick out all the parts and then think logically about all the pieces. So there's nothing over there with x, so I can say x minus 0. Factor a 4 out of the right side, so 4 times y minus 1. And what do we get for h, k, p, and all the other stuff? H is 0, k is 1, 4 times 1, well, 4 times p, so p is 1. Then you can get the directrix, axis of symmetry, vertex, and focus, and then you can draw those things. Check it on your TI 83 with your Conics section app, and off you go. So you probably want some graph paper. You can print some off the internet, or you can yeah, just draw it. It doesn't have to be perfect. It just have to see those key points as you do your homework. Check your sheet for those important things that I want you to be able to bring back to class and the problems you need to try. If you have problems with completing the square, those problems where you have to change the form, bring them to class. We'll talk about them before we grade things. Hope this helps.